We've existed over 7 years. Started off as an IoT company, made a lot of healthcare projects. And going from IoT to healthcare, of course, is a pretty big pivot. And around 2 years ago, we realized that we wanted to make a new flagship product. This was in healthcare again. And first, before I go deeper into how we migrated the legacy backend, when we were about to do this, we had to first make sure that the new products we built are also in line with the new infrastructure that we're going to go towards. And all of our technology at this moment was working with healthcare. So a note about healthcare first. When you're working with healthcare, I mean, of course, we're working with sensitive data. That's a no-brainer. But to make sure that we can get to the next level of doing API integrations, working in mental health institutions, we decided to follow a certification. It's called the ISO 27001. I'm not sure if anyone is aware of it. But it's used for information security practices and also a Dutch standard called the NEN 7510. But one of the biggest problems that we had, or constraints that we had, was that our data had to be kept within the Netherlands. This constraint came because we were partnered with a very big mental health institute in the Netherlands, and they had this requirement. All patient data had to be within the Netherlands. This means we can't go to the public cloud. 2 years ago, there was no public cloud in the Netherlands. Last year, you have Google Cloud. But having such restrictions meant that we had to do all of these infrastructure changes within our own private cloud. A note on the new product that we were building, just again for an overview of the challenges. It's real-time chat and calling between patient and therapists. It's a different product for mobile and web, and it's used by mental health professionals as their core tool. That means any downtime you have, you're burning through a mental health professional's euro per minute. So during work hours, having any downtime is not allowed. So now these are the requirements we have for building the new infrastructure. And at the same time, we want to maintain the legacy code. Our legacy backend at this moment, 2 years ago, by the way, was of several microservices. They relied on each other, made by a lot of different engineers in Python, and PHP, and Go. It was set up on various providers. We had 3 different server providers, all running different databases, some running servers, some running services. And they were provisioned manually by different engineers. And only one engineer really knew how everything worked. It's technical debt. I think something all of you are aware of how it looks like. Deployments were dreaded. People were afraid to fix the core problems. I mean, of course, who wants to touch that code and be responsible for downtime? And downtime usually meant calling the senior engineer. One time we had a 2-hour downtime, and after that, none of us could solve the problem at all. We had to call the engineer. He was on vacation. He found a laptop. It was, in the end, 4.5 hours of total downtime. One of the worst things an organization can face. But we were there, all of us, just couldn't do anything. It was 7 different servers running different services. No idea where to even begin, what to touch. And so we knew we had to fix it, and it's a pretty familiar problem, let's say. This is a common startup problem. I mean, as you pivot, your backend starts to suffer. You start to grow on the technical debt. But one thing a lot of people don't realize is that servers are also part of the technical debt. It's not only the code that faces it. People provision different things manually. Some have failed to ban with different configs on various different servers. No one really knows how it all works. And initially, time to do it manually is actually faster than automating it. And it's fine. You have to solve a problem. You have to run a startup so it can scale. But we were in a position we had to solve these problems and we had to scale. We had to find all of this while building a new service. So how do we fix it? Before we go ahead and start patching these things, what is the ideal picture? We started asking this question within the organization. And in the infrastructure, in the backend team, we agreed, number one, the whole environment has to be reproducible. It's the ideal picture. You can't really achieve it 100%, but you can get as close as possible to it. Developers should not spend time automating things that could be done by machines. Like, why would you manually build and wait? Why would you have nerf wars while it's compiling? We have build servers now. So unfortunately, that excuse is gone. And everything and everyone should be redundant. This was the ideal picture. If the entire backend and infrastructure team left, how long would it take for us to rebuild everything? And we did try to come up with different estimates. It's of course not going to be a few hours. If all the servers are gone and all the people are gone, it will take some time to go through it. But is it even possible? Can you do it in how long? In a month? In a week? In a few days? And we set up these requirements before we went ahead and actually made the steps happen. The biggest problem in startups, of course, how do you bring maximum value when you're performing these steps? And people don't want you to just go ahead and build this ideal picture. You have to show value on each step. And that's why we went with an incremental approach. The first step we did was put to containers. It's something touched by a lot of people in different talks, so I'll try to be short on containers and the benefits they provide. We basically packaged all of our services in Docker into containers. It was a simple bash file to initiate each service. And we had Docker Compose to make sure that all the services that were dependent, that we required in our entire backend, could be in one Docker Compose file. Our containers basically look something like this. We tried to find maximum value from day one. So our services were not built with the concept that anything that it relied on could ever be down. That means you start and you assume MySQL is up. You don't even wait to check if it's up. You don't even wait to check if Redis is up or any other thing you require. And of course, it's a fundamental problem, but no one really wants to touch that 7-year-old PHP code and fix it. We decided to just go ahead and put it in bash scripts. Just when the container starts, the bash script checks if everything it needs is there. If it's there, let's just start the service. If it's not there, just keep sleeping. The container is unhealthy still. To combine all of the things, we were using Docker Compose. It simplifies developer onboarding. Why I'm specifically mentioning this point, we had 14 different microservices, in total 6 different databases and services that we were using on our core stack. It's a lot to run on any machine. You don't even remember how everything coordinates. I think this would also give you an idea why we had a 4.5-hour downtime. It's just too many things connecting in too many complex ways over 7 years, built by people who had long left. But with Docker Compose, our entire onboarding was simple. The README said Docker Compose up, and it has to work. That was the basis of us going towards Docker. You do Compose up, it runs all the containers it requires, and your whole backend is running on your local machine. And before, you'll see in all of these steps that I talk about in my talk, they have this slide, what's the big win? Because people are really opinionated on tools, everyone has a different thing they believe is the best one. I agree, I do not have a problem with that. But fundamentally, we were focusing on the wins, not on the tools used. It could have been chroot jail, not a problem. The whole thing is we need to have these wins. And this is something that I'd want you to focus on in the talk throughout. So it was a major boost for our development workflow. The backend team or new engineers who had no idea how to even configure Cassandra could just do Docker Compose up, set up Cassandra, Elasticsearch, MySQL, Postgres, everything it required was functional. And you can run the whole backend locally. That means you can do end-to-end tests when you have it running locally, of course. You can see how it's behaving all across. The second step, more towards the fun stuff. Infrastructure as code. To make sure we provide value, the reason we picked this up, we were supposed to create a new Elasticsearch container, a cluster. And at this moment, we were like, we know the ideal picture. We have to start somewhere. How about this new cluster that we're starting? Let's try to set it up with Terraform, see how it works. Well, it freed us from vendor lock-in. That was the biggest win we were after. Terraform allows you to specify a provider, and through the provider, you can set up how your entire compute stack, your network, your firewalls look like. And as everything is in a configuration file, you can push it to Git. I'll show you one of the example configs. This is just the staging server that we set up for our MariaDB. It has lots of parameters. There are great tutorials for Terraform online as well. But I'll give you an overview on the key features that I thought were pretty fun when working with it. Here, I'm specifying an OpenStack compute instance. We used OpenStack because we have a local provider in the Netherlands. We rely on it. But they do provide OpenStack as an API. That means if we start using this API to provision our servers, and tomorrow our provider goes away, goes bankrupt, we can just move to any provider that does support OpenStack. The only change we have to do is give it a new authentication token. And if we run our entire Terraform stack, it just reproduces the entire 50 server clusters that we have right now. In the config, I'm specifying a compute instance. We give it the name of the flavor. It's a 2-core, 2 GB tiny instance for MariaDB at this moment. It's a cluster, so we didn't really care. Specify the firewalls required for it. You see I'm defining a variable here for our MariaDB exporter. So this means that all the rules for the firewall are also kept in another file within Terraform. We can specify availability zones. That means it allows us to split our clusters or produce them in different data centers, NL1 and NL2, here you can see. This means, again, load distribution is something that comes in the PR. All of this is kept in Git. Every time you need a new server, you don't need to come up and ask, hey, can I set up that 6-core server for my tiny stack, I don't know, one tiny staging server or whatever. You just do a PR. If the PR is merged, that means your server is there. There are problems that come with whenever you introduce something like this. What if 2 people create or modify a running server at the same time? And there are ways to fix it. We store the last state of our servers in S3, which is locked. So whenever someone starts working with Terraform, there's a clear process that you have to apply it. It's in our operations guideline. And this allows us to make sure there are no clashes or conflicts. Big wins, free from provider lock-in. All firewall rules are clearly documented. This is something I'd like to give emphasis on. I personally think one of the biggest security threats most people face is open firewall ports, or publicly facing firewall ports that you forget about. Last week, there was a breach in matrix.org. Matrix is a chat service, a very secure chat service used by the French government. There was a whole root cause analysis. There are a lot of things that caused the problem, but the first infiltration happened because their old Jenkins build server that everyone forgot about had a SSH port that was publicly visible, and they forgot about it. And I can tell you, it's happened to us tens of times. Sometimes you open your OpenStack page or your cloud provider page and you're like, who set up this temporary SSH? It was temporary 3 years ago. Why is it still open? And this is how you easily control it. It's in Git. It's hard to miss it. The second way for infrastructure as code. Now you're creating servers using Terraform. We still need to provision them. We still need to install software on them. And this is where Ansible kicks in. Again, it's a tool. You can use Chef, Puppet. Really, in the end, it's up to your developer operations team how they feel most comfortable with. But the wins is something that we were after. But fundamentally, for Ansible, it allows you to set up provision any server using roles. Roles is our bunch of bash tasks, basically, grouped together. You can inject variables in them. And the biggest difference of using Ansible is that you don't need to install anything on the server that you're setting up. It actually just SSHs into the server and starts running these bash commands, and then checks the state of it, make sure all software are installed. I'll show you an example config. This is our Ansible config that we use for setting up a staging MariaDB cluster. Again, a YAML file, again in Git. So with this and Terraform, all of our servers, everything that's set up on them is in Git. Comes through a PR, has to be reviewed by 2 developers and then merged. I'll go through some of the cool parts of this config as well. So the first line, we're specifying the hosts in a group called MariaDB. In Ansible, you can specify a group, and here we specify the group called MariaDB. That means all the servers that I list under MariaDB will have the same file run on them, which is a massive saver for clusters. There is no differentiation between MariaDB node 1 versus node 3. You can still differentiate them. You can call someone a master using variables. But what is set up on each node is identical because it's a single playbook that is running on them. And this configuration, by the way, is called playbook in Ansible terms, just for clarity. You see, I'm calling something called env here. It's a parameter that we're using to specify whether it's a staging or a production server. Another major win. The configuration in staging and production cannot be different. Apply the same rules, the same playbook whenever you're setting it up on staging or production. There's a folder called encrypted. So another cool thing that comes with Ansible. When you set up any image or variable files in Ansible, you can encrypt them with Ansible Vault. It's built in, very secure comparatively in the industry. And because your configuration files are encrypted, you can keep it all in Git. The password doesn't have to be in the same place. We share our passwords with only one other operations chief. We have like 2 people who are administrators of the whole stack. And 2 of us have the passwords. No one else does. But the configuration files are available for everyone. So if that new engineer who joins the company says, I want to set up fail to ban, because apparently no one thought of it before, they can just go ahead and do it. That's not a problem. But they don't need to know your root credentials. They just need to know that I want to do this one thing to improve your stack. The operations team doesn't have to have the same level of permission. And this is, again, something we learned a lot more when we were doing certification and compliance. When it starts out, it's something you really dread. But as you go deeper into it, you have to build audit trails. You have to show how you're improving your stack. And these things allow us to fundamentally be ready for compliance as well. Going through the config, these 2 blinds or roles that I'm specifying, available on GitHub, they're open source. They set up a Galera cluster for MariaDB, something we didn't make. The community has huge amount of role for every service, every database, more or less, that you can think of. Ansible will provide a default for it, which makes setting up new servers really easy. I remember we had a new test case recently where we had to set up MongoDB for one of our projects. And yeah, none of us were experts in MongoDB, but we did get Ansible roles that allowed us to set it up quite effortlessly. Of course, there's the whole part of tweaking it. That's something you have to learn. Ansible won't do that for you. But at least it gives you a start. You can start running it and see how it functions in production. Another important point. So Ansible allows you to define your own roles. We have a lot of our in-house roles. We have this one role called the common role, which is applied on every server that we create. And it provides us the default level of security, the default level of monitoring that we need. And it's this huge file with fail to ban, with rate limiting, with you name it. Prometheus set up by default, comes with fail to ban as well. I already said that. Your jail set up on it. And it allows us to make sure that all of our servers have this fundamental level of security by default. In all of our database roles, we also have this backup role, which allows us to uniform our backup strategy. It's a single role which understands what timing to do, where to store your backup, what time the cron command should run. And yeah, basically this one role can back up all 5 of our different databases that we have at the moment. Don't ask why we have 5 databases. It's legacy infrastructure, of course. But we do, and we do back all of them. The biggest win? Our clusters are now made effortless. Again, Ansible supports identical clusters by default. As I said, the tooling doesn't matter. but anything that you use to provision your servers, you have to make sure that clusters isn't extra work. It should not be theoretically possible for them to be non-identical. They should start from this right base at least. All the servers are fully managed in Git. We also ensure that the configuration stays the same in staging and production. And the fourth point, incrementally improve our infrastructure. It's quite crucial. We've had so many CVEs that are reported. You have to upgrade SSL server, for example, OpenSSL in all your servers. If you have 50 servers, you're not going to SSH in everything and update them. But with something like Ansible, it's just effortless to upgrade. Whenever you find a vulnerability, we just apply the single patch on our single role, and then we rerun it across our entire stack. Staging, production, and internal. All of the servers which have this vulnerability is patched by updating any software required. And finally, of course, we have Ansible Vault. It's supposed to be extremely secure, and it encrypts your configuration so you can keep everything in Git. The passwords don't have to be there. So till now, and this was all sequential, we used Terraform and Ansible just to make sure we can create this new Elasticsearch cluster. It was a requirement for the company, a requirement for our toolchain. But before we jumped in creating this cluster, we'd already identified what the ideal picture is. We'd already identified we have to do something about this technical debt of our infrastructure. And till this point, we were just doing this for one feature or one request that we had in our Trello card. Going forward towards orchestrating the containers. So now that we have these servers which are identically produced, and all of our code is inside containers, you have to make sure there's a tooling that allows it to be orchestrated. We all know, at least comparatively, if we look at Hacker News or if you generally follow operations and container research, Kubernetes is winning the battle completely. It's supposed to be the best tool for orchestration. When we started out, we used a UI tool on top of Kubernetes. It's called Rancher. It's very easy to use. And you don't even need to touch with configuration files here. It's just really a click and drag UI. It's packed with a lot of development features to make deployments really easy. And I'll just show you how you can set up a new container in Rancher. So our Rancher environment currently looks like this. We have one server, and then we have 6 agents, 3 for production and 3 for staging. They're set up using Ansible, Terraform, same stack that I mentioned before. And what Rancher does is that you control the server, you tell it what you want, the action you want to perform, and Rancher automatically manages the agent that you want in production or staging, the environment that you're in. So that means when you deploy a new container, you don't know if it's going to run on 1, 2, or 3. It's Rancher's job. You give up control on the instance of how the container is set up, but it provides by default health checks, monitoring, and deployment there. So let's go through steps of creating a service in Rancher. This is really part of the UI. And while taking these screenshots in the slide, I set up another instance of Grafana. You specify the number of containers you need, how much failsafe you require. You name it. You specify the image. The image comes from Docker Hub. So it's an image that we didn't set up. It's literally doing Docker pull and Docker run at the end of the day. But this is about it. You just give it the name of the container and you say start, and Rancher just finds a host that has enough space, enough memory, the best ideal candidate to run this container on, and executes it there. If it doesn't run there for some reason, low disk space, some failure on the host is down itself, could be, Rancher just finds another agent. Anything that it can run on, it keeps trying till it can find an ideal host to run your container on. Well, now you have the image running, but you don't really know if it's running. You've started it. Might be that it started failing. And here comes another cool feature. Provides you with built-in health checks. What we're doing here, I'm just saying hit this endpoint /login. on port 3000. This is where Grafana starts by default, by the way. And I say just hit it and see if you're getting a 200 response. If you're not getting a 200 response, what should you do? Just recreate the container. And Rancher will keep doing it. It'll just keep trying to recreate it till it can make the container healthy. There are lots of alerts it would fire. You can see it in the UI that something is unhealthy. You can read it from Prometheus that something is unhealthy. But it's actually in the part of setting up a container that you specify health checks in really a click UI way. Now that you have your Grafana running on port 3000, and it's confirmed that it's running, because if it's unhealthy, it keeps restarting, you need to set up a public endpoint. And Rancher comes with a built-in load balancer. It has a HA proxy load balancer built into it. So whenever you want to open a publicly facing endpoint, you just specify the name, grafana.mywebsite.com. I say it's going to come on HTTPS. And I just tell it to reroute all requests to port 3000. And that's it. You still need to make sure your DNS is configured, and it's pointing to these Rancher agents, or where the load balancer is running. And Rancher will take care of it. It also allows you to give you a path. That means that for the same URL, grafana.mywebsite.com, I could have grafana.mywebsite.com/test, which goes to another container, just as an experiment. If you're doing it this way, you don't even need a DNS repointing. And by this time, you can see it's so clicky that you don't really need to understand what you're doing fundamentally. Even someone who's not in operations, who doesn't know HA proxy, who doesn't know how to set up their container in production or staging, can just use Rancher to open a public endpoint. Another cool feature that comes built into Rancher is the webhooks. So here you can specify, firstly, what action Rancher should perform whenever it receives a webhook. We've set up a webhook right now that says to upgrade a service whenever an image is pushed that has a tag of staging to it. This is something we cannot use right away, but if you think about it, if you were using something like Docker Hub, which fires a webhook, or maybe you're not using Docker Hub, you're using something locally. Anything that can fire a webhook, which pushes an image to with the name of staging, Rancher just knows to upgrade the service and pull the latest image. And this is actually the fundamentals, or laying the foundations for continuous deployment. And in the next win, we'll start seeing how we get there. So the big wins with Rancher, it's easy to manage your cluster for your services, because you have 3 Rancher agents. You can point all your DNSs there, and Rancher just knows where to run containers. Just make sure something is healthy. Just make sure that it's functioning. Keep checking the health checks. And if something is failing health checks, it would just move the service to another instance, to another host. It has a built-in load balancer and health checks. It has a built-in local DNS resolver. That means you don't need to really find out where the container is running. You just give it the name of the container. It could be running on any agent, but Rancher will find out a healthy instance and pass requests to that container. It has a UI with access control. We use it extensively. We have a built-in LDAP. That means that we give our developers access to staging freely. We give some developers and researchers access to our testing infrastructure. And this means that anyone who finds a nice Docker image that they can run, they want to test. An example would be, recently someone found we had a requirement in our product to upload photos, and someone wanted to experiment with a service they found on Docker Hub. We're like, it looks cool, needs nothing, just one Redis instance, and credentials to S3, and it could just upload images. Now normally, this goes to the operations team, which has to figure out what to do, if it's healthy or not, set it up, find out pros and cons, and then there's a whole battle with the app team to basically judge if it's usable in the service. But in our case, it basically was someone got an idea, they had access to it, they went to the staging server, They set up this photo upload service through Docker, tried it out, made it run through the morning in the app team, and by the afternoon they realized it didn't have a couple of features they required, and they just deleted the service. And for me, this worked really well because half of our team is in Indonesia. So all of this happened before I even woke up. They just woke up, tried something, it failed, and then they were like, oops, doesn't work. And I just found out the result in the end. And for an operations team, this is ideal. It was so much time that was saved in this just one exercise. And I think we've done almost 14 to 16 different internal services in the last year using this stack. And of those, 4 have survived. The remaining were discarded because they didn't serve our purposes. But none of them were started by the operations team. They were done by the staging developers because they have access. You can just go on Rancher and do it. And it's ready for continuous deployment. The final win from Rancher. We're going to see how. So of course, that's what the whole conference days are about as well. Continuous deployment. Now that we have Rancher, we just need a webhook to upgrade our container. The final glue that we set up, we used Travis and Docker Hub. So currently what happens in our code, there are a lot of benefits for it, but I'll just show you a visual of how it looks like. So what happens in our code at the moment, you push to develop on GitHub. Our code is still on GitHub. And whenever a commit is received, Travis starts building. Travis tests your code. It turns on some bots to check with linters the code quality of your code. And once everything is functional, once Travis reports success, it builds a Docker image, pushes it to Docker Hub. Then once it's pushed to Docker Hub fires a webhook onto Rancher. And when Rancher receives the webhook, Rancher realizes that the staging image for our microservice has been updated and instantly pulls this new Docker Hub image and starts the new service. You might be thinking, it seems a little too easy. There must be some catches here as well. What if the service fails? What if you do a bad commit? You don't want it to be running in production specifically. We do this primarily for develop. For production, there is still a manual check just for sanity to make sure it's functional. Whenever we push to Docker Hub, at the same time, we push on Slack as well, telling our QA team that a new release was just done. So the QA doesn't need to be notified for releases. It's done by the CI. We do not tell QA what they have to do. QA sends it a Slack message, the operations team in production, saying that this was successful. They also do it in beta. And when we receive their success message, only then do we upgrade our services in beta and production. For staging, or in all of these environments, if the service fails, if there is a bad commit that causes it to become unhealthy, Rancher firstly allows you a one-click rollback. There's just a button on the top right which says rollback, and it will just swap the image to the previous version. But to make things more redundant, we don't only push on staging or production, we also push the version of the Docker image. That means worst case scenario, you do a commit, it's healthy, QA passes the check, and production says it's failing. We just need to specify the last version number and roll it back. So there's no manual need for reverting. There's just operations team specifying the version they need for successfully running the code. Of the big wins, well, developers don't need to touch the infrastructure. QA notified for release, otherwise we do a rollback, and everything is in Docker Hub for easy rollback to any version. After this, basically by this point, we're ready for staging in production more or less, but at this moment we're gearing up for our final move to production. And of course, all the points that I mentioned to you till now were the first almost 6 months of effort, setting up a cluster, finding value and fighting for the developer time each month, trying to get a sprint out for our own tasks. And we've been running this stack for over 1.5 years. And in the last year, we've had a lot of new things that we've learned, almost in 2 years. And key lessons that I'll share in these slides. We now have end-to-end health checks. we added a status point to all our microservices. This endpoint returns a 200 status and the time it took to get a response from the service. Why do we show the time? Just to give you an idea, it was very free to add. It's just we were already doing the requests on everything the service depends on, so why not just add the timing? And there's one point, we had an old caching mechanism that somehow was failing, we didn't realize. There was no alerts for it, and it was very weird. Just performance was very sluggish. And because of these response time, we realized one service, when interacting with one specific service, was taking 15 seconds, and every other scenario was green. And just having these simple millisecond numbers into your code allowed us to instantly debug it. Configuration management. Learned this the hard way. Our configurations are on files. We really cannot convert them to any other format. There are 14 different legacy services, PHP, Go, Python. You really don't want to be touching that code. What we did, we put all the code, the configurations encrypted into Ansible. That worked quite well, but there was still a catch. What if someone runs Ansible? That means the configuration files are updated on the servers, but the code that's currently running in production did not restart. So it's still loading the old configuration from the memory. This causes major problems. Someone updates Ansible with a bad configuration, production is running fine, no one saw a problem. 2 weeks later, some poor guy restarts the container, bam, everything goes down. And we have no idea why. It's just the configurations were updated 2 weeks later. Hell of a problem, thinking how to solve it, and in the end we solved it with one line. We just added it to our bash script, to supervisor. We use supervisor to run all our legacy services. We just added this one line that checks if the configuration file was modified on the root volume, on the volume where the actual configuration is stored. And if this file was modified, we just restart the service. That means anytime someone pushes a new config from Ansible, even if it's bad config, the container instantly restarts because the file was changed at this moment. And after the container restarts, you instantly know something was wrong or right. So the person who ran the Ansible command would realize it was their fault, not the person restarting the container. Building a whole operations culture, it's a very big point. As an overview, we have Prometheus to monitor everything. We now have an on-call duty. Incidents go to Ops Genie, and we send alerts based on severity. If there's something is an alert, it's just a push notification. If something is an incident, that's when you get a call on your phone saying you have to drop what you're doing, you have to fix the servers. Of course, making an operations culture is not something you do overnight. It took us a lot of time, but the reason we were really lucky to be able to do this was that we made sure that we have a lot of health checks on our services, and not only within our stack, but also externally. Because if we have everything being monitored within our stack, who is measuring our provider? We're not measuring on Google Cloud. We have a low provider within the Netherlands. They provide pretty good support, but if they're down, they might not say they're down, but they might actually be down. So there needs to be auditability for everyone, not only our code, not only our stack, but also our provider who provides the real, actual physical stack. And that's why we keep pinging all of our external servers from external locations, seeing if it's actually responding. And this is what we use for our, also to review contracts with them. Finally, the results. Of course, there are a lot of things that are immaterial, and there are a lot of things that are measurable. I think I'll just end the slide on the point that it's actually measurable. We had a total 16 minutes of downtime in 2019. And this is production anytime from a location in the world. We checked from 70 different locations, pinging them. If any minute, within 1 minute accuracy, if our services did not respond, we considered it a downtime. And of these 16 minutes, 8 minutes were because of our provider. I think that's pretty much it for me.